If you're somewhat familiar with date and time functions, or you have completed Book 2 in the Joes to Pro series, this will be a simple throwback for you where you do the select get date function and it shows you the date and time that you ran the function. Looks like for me it's September 19th, 2009, and it's in the early afternoon. Well, what does this function do, sysDateTime? What's the difference between getDate and sysDateTime? Let's run these because they're both going to produce the current time in my time zone. And this top one is 2:40 and 33 seconds, 0.070, and this is 2:40 and 33 seconds, 0.0736432. So it looks like getDate produces a time down to the milliseconds, and sysDateTime produces a time down into the nanoseconds. Well, according to these two times, I guess everybody's about finished with lunch. But maybe at this very moment, somebody in Japan is fast asleep because it's the middle of the night. Or somebody in England has just finished their dessert after supper. What time is it in UTC time? There's a function called getUTCDate. Now, let's run all three of these select statements. We can see the time in my time zone, which is the Pacific time zone, and in England right now, it is September 19th at 21:41, which is basically 9:41 p.m. But notice getUTCDate is not nearly as precise as the sysDateTime. Well, there is a UTC function that will get you down to the nanoseconds, and that is sysUTCDateTime. Let's run all four of these select statements. And we can see here's my two times in my time zone, and here's the two times listed in UTC time. In our DB Basics database, we have a table called Activity, which tracks what library card number has checked out what book. Do you suppose we should track the time they checked the book out and the time they've checked it in? Yeah, let's expand our design by right-clicking the Activity table and saying Design. We're going to have a field called Check Out Time, which will be a date time field. Let's save this table, close out of here, and let's update the activity for library card 1001 to the getDate function, which goes down to milliseconds. Let's see those milliseconds. Okay, this was checked out at 9:19 at 3:14 p.m., 16.370 seconds. Okay, now let's capture the more precise nanoseconds for library card number 1003. It says one row is affected. There's the row right there. How come it doesn't appear any more precise? Well, the date time is only going to store milliseconds, even if you provide it with nanosecond precision. There is a data type that will hold nanoseconds, and it is new to SQL 2008. So let's go and do the check in time as a new field, and let's go to date time 2. Save the table. Now with the check-in time, we will make these update statements. Okay, let's run this first update statement. This updates 2 records, and let's look at those records. Okay, let's give ourselves some space, and it looks like, yep, it goes to nanoseconds, but why are these all zeros? Because getDate only provided it to milliseconds, so SQL padded the rest of the precision with zeros so it fits. Well, the sysDateTime will produce a more precise time in nanoseconds. Let's run this. And then run the query. And look at this. We are filling the nanoseconds up with time from the sysDateTime function. Let's take a trip back to the JProCode database and look at all of the records of the current products table. Now notice we have an origination date which is of date time. It captured the time in the time zone that we ran it, but it did not record which time zone we ran it in. In other words, if you were to ask what time was it in England when this ran, or what time was it in India when this ran, you would have to know, well, what time zone is this stored in? And that date field is not storing that information. So what we can do is we can have a field that stores the time and the time zone you recorded it in. So if you need to move or query the data adjusting for a time zone, it becomes a cinch. We want to alter the table, current products, and we're going to add a new field called origination offset, which uses a data type called date-time offset, and we'll set that to being allowed for nulls. Okay, command completed successfully. Now let's query the table just to see what we have. Let's query just some of the fields so we don't have to scroll so much. So what I've got here is a select statement that looks for product ID, product name, origination offset, and of course, let's put both date fields in there so we also have origination date. All right, let's run this query. And there we have our original origination date, and we have a new field that's ready to hold the origination date plus the time zone that it was recorded in. Well, we can do that by calling on a function called toDateTimeOffset. For example, let's update the DBO current products table, and let's set the origination offset to be equal to the origination date. Now that's not quite good enough, you know why? The origination date doesn't know what time zone it's in, and the origination offset, being of datetime offset, wants two pieces of information, the time and the time zone it was recorded in. Well, we can actually capture that if we get a little more elaborate after this equal sign by saying toDateTimeOffset, and then putting in the time and then telling it which time zone we are in. Now, the Pacific time is -8 hours after England. So let's do -8:00 of Greenwich Mean Time. End it with a parenthesis, and this should update every single record since it was recorded at the headquarters in Seattle. And we get an error. Why is this? Because one thing that's very important is it needs to have the same number of digits. So -08 would be the proper way to use this parameter. Okay, 485 rows have been updated. Let's see what it looks like. Okay, this was originated in 2006 on August 11th at 1:33 p.m. And that's exactly when this one was originated, in the Pacific time zone. Notice another difference, because this date-time offset is a date-time to precision with a time zone in it. Now, how is this handy? Why would this be useful? Well, you can query on the fly to see what time everything was done in another time zone. For example, the one-day West Coast tour, what time did that originate in India? Well, India is plus 5:30 of Greenwich Mean Time, which is 05:30. So I'm going to run a select statement that looks just like this other select statement we have up here. But we're going to take this origination offset and put a switch on it. SWITCHOFFSET. This to what the time would have been if it was in India. Okay, let's give that a run. And we can see when it is 1:33 in Seattle on the 11th of August, it is the 12th in India at 3:03 in the morning. If it was October 3rd, at 11:43 p.m. in Seattle, it's October 4th at 1:13 p.m. in India. If you have a date-time offset field, you can use the switch offset function to see the equivalent time in another time zone. Lab 4.3, Skill Check 1. Add two new fields to the employee table of JProco. Add a nullable field called hired offset that stores a date-time offset data type. Add another field that is a char6 called time zone. Then populate all Seattle and Spokane employees with -08:00. Populate all Chicago and mobile employees with -06:00. Populate all Boston employees with negative 05:00. After these steps, your employee table should look like the figure you see here. Skill check 2. Use toDateTime offset to populate hired offset from the hired date and time zone fields. Afterwards, your employee table should resemble the figure you see here. Skill check 3. Show the hire date for all employees in Alaska time, which is negative 09 hours from GMT. Afterwards, your employee table should resemble the figure you see here.